Tim Wilson, senior partner at Analytics Demystified. He's also a renowned speaker and writer, author, blogger at least, and is one of the co-hosts of the Digital Analytics Power Hour, which is, if you're in digital analytics, I highly recommend you listen to every episode. And yeah, so we're really, it's actually his second time speaking at Seer. He spoke years ago back at the Search Church, so now he can tick off the Search Church.
Haven't cut my hair since.
Haven't cut his hair since. Looks good. So everybody, Tim Wilson.
Thank you. I do feel like I should be eating a souffle. So the machines are coming. I feel like we've kind of mingled. I want to start off. People have gotten to know each other, so I feel like I can get a little personal starting off. So I'm going to admit that I am an addict. I am an Excel addict. So show of hands, how many people here, maybe not addicts, but how many people are Excel users? Everyone, you guys too, everybody's streaming. We're watching. We got the NSA on it. I'm looking at you. Okay. Somebody had to talk to the camera. So how many people here are using Excel less today than they were, say, 3 years ago? About half of the audience and 37 of the people watching remotely. So why is that? Well, there's a lot of other tools. Excel's kind of been it's going to be around for a long, long time, but a lot of people are slowly moving away from Excel for a lot of the stuff that they're doing. A lot of people are moving to Google Sheets. It's come on strong. It's added a ton of functionality, and there are benefits to using Google Sheets. There's a whole class of tools that, broadly put, are just way better than Excel. Better visualization, better ability to connect to multiple data sources, better collaboration, better ability to slice and dice on the fly. So there's that whole class of tools that is slowly kind of chipping away at Excel. And then there's this other class of tools that are data programming tools, SAS and SPSS and Python, R. So those are all, I think, kind of taking some of the Excel usage away. But if we step back and say, what is it we're really hoping we get to, that migration away from Excel? And what all the buzz is these days is that we're moving towards the world of HAL 9000, that we're going to get to the world of, I've fully optimized your marketing, Dave. People recognize, we check how young this crowd is. So if not HAL 9000, then think IBM Watson or Google DeepMind. And the idea is that we're thinking that we're in the world of Excel, where we have to pull the data, do a bunch of stuff with it, manipulate it, slice it, visualize it, take it, and then digest it and say, based on what I'm seeing, I'm going to take an action, and then rinse and repeat. And the idea is that the machines and AI are going to come and they're just going to run all this stuff for us. So how do we actually get from Excel to that world? Well, one, I don't think we're really going to get to that world. And are any of these tools kind of moving us in that direction? And it's not really about the tools, or it's not just about the tools. At the end of the day, to get from this world of Excel and these files that we're working in to the world of machine learning, we actually do need to think about the data differently. And some of those tools, I think, are forcing it a little bit more than others. I've been on a journey to learn R for the last 2 years. And what I quickly learned was, yes, there are the mechanics of learning the syntax of this open source programming language, but there's a lot that's going on in R where I had to start thinking about data differently. And I had to learn some level of statistics and understand how statisticians and data scientists think about data that was very, very different from how I, as a 15-year-plus user of web analytics data, had thought about data. So what I'm going to do is I'm going to dive into one stupid, simple example. We're going to start with an example that I would be shocked if 100% of the people in this room have not gone in and answered this one question. How much traffic did we get last month? So I'm going to use this simple example because we can all relate to it. We can talk about whether traffic is ever a good KPI or not. That's not really material, but we're going to see what we can do that hopefully will get you thinking about data a little bit differently, which will hopefully start to help you realize where the data scientists and the people who are building those machines, kind of where they're coming from. So you're not going to walk out of here as a data scientist or a statistician or fully able to go and build a machine, but hopefully have a little bit of a glimpse into how there are ways even with the data that we're used to looking at, there are ways with very straightforward or very different ways of actually digesting that data that actually starts to have the ability to reveal some things that we don't historically ask ourselves. So if we have this question, in my example, it was real data, there were 130,712 sessions last month. Any web analytics, super easy to get that. We know we're going to need a little bit of context. That's not enough. We want to compare it to Target or maybe we just compare it to last month and say that was 17% growth over the last month. And chances are, this is a matter of course, we want to break that traffic out by channel. Very, very common. Also, totally something we do. The Google Analytics, default channel groupings looks like this. We can build a bar chart like this. So here's where we're going to shift things a little bit and say, how many rows of data went into this bar chart? And I've built a bar chart like this more times than I possibly count. It was actually a pie chart earlier. I was frantically editing my slides. No, I wasn't. I hate bar charts as much as I think every speaker here. So I would look at this and say, well, this is pretty easy. This is clearly 8 rows of data. We've all built bar charts like that. So, okay, that's not too surprising. But if we ask a data scientist and said, here's the chart, how many rows of data went into building this chart? Most data scientists, I would posit, would say 130,712. Because they would say, you've rolled this stuff up, but the fact is, those bars are built up as a whole bunch of individual observations, or what you web analysts call sessions. And in their minds, the assumption is this is what the data table looks like. Every row is a separate session. Every row is a separate observation. So this is fundamentally the difference between aggregation and observations. And frankly, that's going to be like the one big point that I'm going to labor and beat on so hard for the next 30 minutes that hopefully you guys are still with me when or at least are still here when Leah's ready to speak. So statistics is kind of is typically built for working on a sample of observations from a population. And that's very different from how we think as web analysts, because we don't really think about, we don't have sample data, or we hope we don't have sample data, right? But the sampling that Google Analytics does, we'll touch on that in a little bit. We're typically, for a standard report like that, we never have to worry about, if we want to know how much traffic came from paid search, we don't need a sample of the population and then estimate it. We just have the total. But if you start reading up on statistics, it's always talking about samples and sample sizes. Like how do we equate that to this data that we have? And that's because we're working with this aggregated data from a population. And the web analytics platforms, Adobe Analytics, Google Analytics, Core Metrics, Web Trends, you name it, their web interfaces are always giving us data that has been aggregated. So here's the interesting thing. The two major web analytics platforms in the US, Adobe and Google, have both implicitly started acknowledging this need for observational level data. So show of hands, how many Adobe Analytics users do we have? A handful. So Adobe's got their data feeds, the completely unreadable. Adobe also a design company that does not design awesome interfaces. But it used to be with Adobe's data feeds, which are hit level data. You used to have to pay extra. You had to work with client care engineering to set them up. And slowly over time, it's gotten to the point with Adobe, anybody who has admin access can go and configure what fields they want included in their data feed, how often they want them to go, where they want them to put them, and put them into a data warehouse. And that's hit level, observation level data. Adobe doesn't talk about a ton, really kind of wants you using the Marketing Cloud where they kind of do all of that for you. But they've clearly had pressure from companies that say, we just need the raw data. We don't need analysis workspace. We don't need ad hoc analysis. We don't need Adobe Insight. We just need the raw data. So Adobe clearly moved in that direction, and I think everybody knows how Google has done that. When they rolled out Google Analytics Premium, now GA360, there was this, hey, just flip a switch and you get credits. You can push your data straight into BigQuery. And a lot of web analysts, and I'll put myself in this, sort of misinterpreted that when it first happened. It was, yes, the yellow bar is going to go away. I'm going to get unsampled data. which is true, but kind of missing the fundamental point. The real key is that that's visit level data, observation level data, when you get the data into BigQuery. And Google has been more open about saying, yes, a lot of the tools they're developing is because they're expecting to be working off this observation level data. So they're sort of our true view of the world. Is this 8 rows of data, or is it 130,712 rows of data? So is there a middle ground? Is it one or the other? Do I have to have BigQuery, or am I stuck in this totally aggregated world? Well, we can deaggregate, which moves us towards that maximum detail. If we just add one dimension, we can go from 8 aggregated to 8 different levels to 24 or 240. So this was a 30-day month. If I add a secondary dimension of date, I now have 240 rows of data. Another way to kind of just to be clear to think about that is, if you could put your channels across the top, dates down the side. If I add all these up, I'm still going to get 130,712. Maybe I color code them because this is a data visualization theme, so I got to try to work some visualizations in as much as possible. So that moves us towards the observation level data. Not very far, but a little bit, and that's actually enough for us to dig in and do some things that are maybe a little different than we normally think about the data. So what we're going to do is look at the variability of the data. And we're going to start just by looking at paid search. So if I want to know, the total was 29,000 sessions for the month, but how much did that vary day to day? Well, I can do a simple line chart and I get a sense of sort of how the data varied. And I could say, well, if that works for one channel, then let me see if I can give Leah an aneurysm by doing this horrendous line chart. It turns out I can't actually get a lot that's too useful out of that. So instead of looking at that, we're going to take a little bit of a leap that if there are any like total purist statisticians or data scientists or academics in here, you might fall out of your chair. But I'm going to say, for now, let's ignore the time aspect of date. So when we typically look at this data, we're saying second comes after the first, the third of the month comes after the second, the fourth comes after the third. But if we say, you know what, we're just going to treat that as kind of a marker of our observations and the order doesn't matter. And if we do that, we have some other visualization options. So we can, if we do that and we go back to our paid search example, then we can shift our y-axis down to the x and put buckets and make a histogram. So this is saying of those 30 days, there was one day that had somewhere around 700 sessions. There were 13 days that had somewhere around 1,000 sessions. And all of a sudden we're thinking, oh my God, I've got a distribution. If I have worked in web analytics data, there's nothing that shows you a distribution of observations. And you start reading about statistics and you're like, well, where's my normal distribution, my assumption of normality, skewness, kurtosis? How do I have a distribution? Well, all I had to do was say, it's cutting a little bit of a corner, but I'm going to use date as just a way to deaggregate my data a little bit and then do a distribution from there. Now, I can take this and do something that smooths it out. Instead of doing a histogram where I put the blocks in, this is called a density plot. So I haven't now had to define my different buckets. Gives me a smooth curve. The y-axis starts to get a little harder to interpret, but you can see that's kind of the same distribution as the previous slide. So now we'll do the same thing we did with our line chart and say, well, if I've got this for paid search, what does this look like if I do it for all channels? And it's equally pretty messy, but you can start to see that there are different peaks in different places. And statisticians really love talking about distributions and the spread and the height and the, how tight. So these don't all look perfectly normal. They're not going to, but you start to see that these channels are kind of different. They all have a different profile. So we'll get to why we're doing this here in a minute. But this is still kind of messy to look at. So we're going to use one other type of visualization. We're going to use the old box plot. And statisticians absolutely love box plots. So for a refresher for anyone, now we can just, even without knowing how to interpret a box plot in detail, you can say, yes, this clearly is showing me some sort of spread in the data and some sort of concentration. But to get more precise about it, this is representing all of those data points, but we'll take paid search as our example again and say the line in the middle is the median. So I have 30 data points. My median is right at 1,000 sessions. The box represents the second and third quartiles, which means that whole gray box represents half of my observations, 15 days of data. And then the whiskers represent all of the data, except you don't want a couple of outliers to falsely show a spread of data that they're just kind of seeing the data. So there's a little calculation to identify outliers. So why does that matter? Well, I can start to see the variability between the channels. So I can see that referrals are very different from paid search, where the median is, how much they spread, sort of where they're centered. But we're eyeballing this, but if we want to move towards the machines, they need to start having some rules where they can say they're not just going to eyeball it and say, is this really different? They actually need to be able to have a mechanism to objectively say, these two things happened and they do actually look different. So now I've been a little bit deceptive. It was a 30-day month, 240 data points, and this is actually only those 26 days of the month in my box plot. The full box plot looks like this. So I'm sure if anybody was reading really closely saying, what the hell kind of website has referral as their #1 channel by far, far away? Well, it's a website that has 4 massive outliers in their data. So this is useful. I may want to say, well, let me go figure out what those outliers, what caused those. Let me go back to just a time series chart. And lo and behold, on the 27th of the month for this website, it just went berserk. So I can track down where the data come from. Oh, Walmart.com. Turns out we did a promotion with Walmart who pointed traffic to our site for a couple of days late in the month. So those are outliers. I need to identify them. Hopefully I didn't just take my initial bar chart and say, man, referrals are killing it. I would have had to dig in some way. And I might have done this to get there. But this has kind of backed us into seeing there are outliers in the data. And we don't want to just remove outliers, but we don't necessarily want to keep outliers depending on what we're trying to understand and figure out. And if we're trying to use last month's data to understand something about channels and sessions, it would be a little dangerous to draw big conclusions without removing these outliers. So basically, these outliers are going to screw up whatever analysis I'm going to do, which gets me mad. It doesn't actually get me mad. It gets me to use MAD, the median absolute deviation. This is another little bit of a shortcut that purists may say there's kind of an art and a science to when you want to use median absolute deviation. But it's this cool technique for detecting outliers with relatively small sets of data. So most people have heard of standard deviation and statistical process control, and you say, if you take my standard deviation and anything that is plus or minus 2 standard deviations, I'm going to call an outlier. If you try that on 30 data points with massive outliers like this, your standard deviation is going to be huge. It's only going to remove a couple of these points as outliers. Whereas median absolute deviation, and it's actually, you can follow how it's a clever little thing. It's got one little mystery multiplier number that you use. But when you apply median absolute deviation, it flat out will identify what visually is clearly these are the outliers. So we don't always want to keep outliers. We don't always want to throw them out. We want to dig into them. But outliers are one aspect of deaggregating data. If you're doing an A/B test and you're not using conversion rate, you're using revenue per visit or average order value or total sales, you better be pulling the data at an order level and having some sort of objective mechanism for removing your outliers, or there's a very good chance that you could completely misinterpret the results of your test because some one snowflake order for $100,000 came in, and if you hadn't identified that as an outlier and remove it, you may completely misinterpret which one of the tests won. So we're continuing down the path of taking some pretty quick little shortcuts for the sake of illustration. I'm going to run this median absolute deviation calculation on all of my channels. So for each one of them, each channel, remove the outliers. And now my box plot it's got fewer outliers. Box plots use a different rationale for identifying outliers, but you still got a few of those blue dots. But now I've got a fairly clean set of data that I may want to look at. So now I'm going to ask the question, is there a real difference between channels when it comes to the number of sessions coming to the site? The answer is yes, because we are going with a stupid, simple, obvious example. Of course, different channels are sending different numbers of sessions to the site. But that's kind of for illustration purposes. This technique, once you get the intuition for it, can start to work in much more subtle ways where we can have a machine saying, am I looking at something where there's anything but noise going on here? And this is conceptually what's going on. When I look at these channels, I'd say, are they really different from each other? Well, how would I figure that out? Well, I'm going to analyze the mean and the variability of where these different channels fall. And visually looking at this, it's clear that referral is different from paid search, is different from organic search. But the way that I'm visually doing that, kind of eyeballing it, an analysis of variance or a one-way ANOVA actually mathematically calculates, does it look like different values, different channels have different numbers of sessions? And I run a one-way ANOVA, pretty straightforward, not to actually work through the calculations, but for a package that'll do a one-way ANOVA, it'll produce results like this. And you can look at it and you're like, well, clearly, I mean, this is kind of an obvious no-brainer. I can look at those words and I can clearly reject the null hypothesis. And hopefully some of you are saying, what the hell just happened? We just went from these nice visualizations to a bunch of shitty text output. And that happens. We're starting with something very simple, very obvious, and all of a sudden we'll jump into this because as we extend to applying these techniques in multiple dimensions and in multiple ways, we can't easily visualize them. So we have to get to the intuition of what was being interpreted there was that it was a very small p-value. And we all heard of p-values. Basically, those text results were saying we can be reasonably confident that there's a real difference in sessions across different channels. Now that doesn't tell us which channel's different. It just says, yeah, channel seems to be something where there's some sort of difference in the number of sessions that get come to the site. But I could go farther. We get a little bit out of my comfort zone. This is the output, or it's a visualization I came up with for the output from what's called a Tukey post hoc test. So post hoc means after hoc. I don't know what hoc means. After analysis. Anybody Latin? Is that Latin? At least is it Latin? Post hoc? Somebody has to have had a Catholic upbringing or something. No? Okay. I think post hoc means after analysis. And Tukey is one type. And what this is doing is looking at every pair of channels and saying, does it look like they differ from each other? And not surprisingly, yes, most of our channels appear to differ from each other. They have very, very small numbers, very low p-values, so it appears they differ. If it's not clear, I'm not, whoa, hello, whoopee. Everybody close your eyes. Wow, I just like sat on it. That was awesome. Here we go again. Come on back. We're going to run this in reverse. Is this like, Tim, you're moving too slow. Pick it up. You're losing the crowd. Just get them to the end. So what we're going to do, so it says most channels are different. That's not surprising. Let's look at one of them, though, where this says the display and video from this ANOVA with a Tukey post hoc analysis says display and video, we're not super confident saying that they actually differ when it comes to the number of sessions they send to the site. And if we go back to our box plot, sure enough, if we look at it, their medians are pretty similar. Their spreads kind of highly overlap. We might say, yeah, I don't know that I'm super confident saying that video and display are really that different when it comes to this metric. So obviously we could eyeball all of that. This was kind of let's do a simple example to sort of illustrate how we can kind of dive into the data a little bit differently in a way that statisticians are kind of comfortable diving into it. But we could also say, that was a one-way ANOVA. What if we introduced just one other dimension, device category? And then we wanted to ask a similar question. Do these actually affect the differing number of sessions? Could be sessions, could be revenue, could be conversion rate, pick your metric. Well, now we can do a two-way ANOVA. If we had n the number of dimensions, we'd be doing an n-way ANOVA. And this is why you wind up with those text-based outputs, because once you get beyond a couple of dimensions, it's really, really hard to visualize this stuff. So the idea with a lot of the statistics is that you take a simple example, you understand it, you build some intuition, which hopefully maybe you have a little bit, this analysis of variance, how much does it vary, where is it centered, We get to these p-values. When you start doing a two-way or an n-way, it's the same thing. The output looks a little longer. It's text-based. It's ugly. But you can start to kind of internalize what it means, and you can start to understand how a machine could be used to use that same sort of output to make decisions of this actually differs. This is meaningful. I'm not going to draw a conclusion that display was greater than video because it doesn't really, I can't make the call with the data that I have that I'm confident that those are actually different channels. So a ton of statistical techniques basically require moving away from aggregation towards observations. So in a way, all we've done is aggregate the data. That's not getting us to observations, but it is deaggregating the data a bit, and we can do, even with minimal deaggregation, we can do some different things. So I took that big old shortcut and said, let's take time and just assume that time is just a marker or just an ID for an observation. We're going to do one more example that is very similar from where it starts, but we're going to do something totally different with it, and we're totally going to embrace time. And if you're not excited already, it's the second example that, like, when I got super excited about some of the possibilities of doing this sort of thing with data. So this other example is going to be, did that metric move enough for me to care? And I don't care what the metric is, sessions, revenue, conversion rate, it doesn't matter. When we do a weekly report and we report our KPIs and we provide some context, here's the actual number, here's how it compared to target, same week last year, inevitably somebody, we're like, we've got to have a trend. We need some context. So maybe I'm showing the last 7 weeks of data, and that last point is last week's data. And I can look at this one again, kind of, oh, clearly it looks like it dropped more than would be normal. But how do we know? How much of a dip or a spike is enough for us to say, we should dig in and look at that, versus this dip or spike was slight enough that it probably was just noise. We can eyeball it to a point, but how much would that have moved where we'd say, we need to go and dig into this? So with this example, we're going to do a deaggregation thing again. Web analysts, all the data we work with is aggregated. It's all aggregated over time. If we're looking at last week had 7 days. So we aggregated across 7 days. Those 7 days were across 24 hours. The 24 hours were across 60 minutes. So we're going to do something totally different called a Holt Winters forecast. And we're going to start by deaggregating our weekly data. We're reporting out the weekly data, but we're going to break it down into daily data. And I mean, even in Jocelyn's presentation, we got to see, everybody recognizes this, right? Many companies have websites where the daily data shows this. We don't want to look at it this way because it's messy, the sawtooth of the dips on the weekends and the humps in the middle of the week. But it's actually good to look at the data this way if we want to apply a little bit more statistical rigor. So we're looking at the last 7 weeks. We can split that up. We've got last week was our data of interest, right? The last 7 days. And even here we can see that it went down. But we keep saying it went down. How do we know it went down? Well, because we've got context. We've got 6 weeks leading up to it for context. And we can think of that data for context as training data. And we're actually going to build a model and build a forecast using our training data and use that to objectively answer the question, did last week's data move enough for us to care? So we're going to get rid of take just our training data, and we're going to decompose it. So we're going to break it down into 3 buckets. So we look at it, and we're so used to seeing this weekly hump, but what do we do with that? Well, that's 7-day cycle. That's 7 days seasonality. If we think of seasonality as being annual, we've got holiday and back to school. Well, we also often have a weekly season. And what we can do is say, let's figure out what the best fit recurring curve or set of data we can put that most explains our actual data. So this looks very similar, but in what the seasonal breakout is, the Monday is exactly the same number for all 6 weeks. The Tuesday is a different number, but it's the same for all weeks. And let's take that and say that's our seasonal component and figure out what that is. We take that out, and what we've got left, we basically put a moving average on it, or exponential smoothing. And that shows us kind of how the data is trending with that seasonality removed. But we had to do a little bit more manipulation of the data to do that. So the thing that's left is we take those two values, subtract them from the actual value, and that gives us a third component, which is the noise or the random. Okay? So if I draw a vertical line through any part of this chart and I add up the seasonal value, the trend value, and the random value, it's going to exactly equal my actual value. And these look three very, very different things because I've decomposed this time series data. Because I've done that, I can now say I want to forecast for what the next 7 days should look like. And I'm going to use the two parts of that signal to do that. So how do I extend the seasonal? Well, that's easy. It's the exact repeating 7 values. So that's a piece of cake. So really, I'm just taking that trend value and just kind of extending it. There's a little math involved there, and that gives me a forecast. Is that visible on the? You can see. I realized did I get the gray shaded the right amount? So I've used those 2 points to forecast what I expected to happen last week. But I know my forecast is not going to be perfect. But how not perfect will it be? Well, I've got that noise, that random component. And that random component may move like this. Or random component may move like this. The more that it varies, the less certain I am of my forecast. So I can use the variability in that random component and put what's called a prediction interval. So this is a 95% prediction interval, which means, very simply, 95% of the time, if nothing drastic changed, then I would expect my actual results to be within that gray band. Prediction interval similar to a confidence interval. So now I can come back, put my actual data back on here, and I've given myself some really meaningful context where I can say 4 out of the 5 weekdays last week, not only was I below my forecast, I was below my the lower bound on my 95% prediction interval. Something does look like it warrants looking into. So in practical terms, like I've got a client where I do a weekly report. They've got 7 key metrics, and all they get is the weekly totals. But I've got a script that runs and does this exercise on all of those metrics at a high level. It actually runs through and does the same exercise on each of those metrics for each channel and for each of their customer segments and for each channel and customer segment combination. And it counts up how many days was I outside of that prediction interval, positive or negative. So that's not machine learning. That's just the machine looking, deaggregating, cranking through a bunch of stuff and telling me, hey, something went squirrely with paid search last week. You might want to dig into that. Or something overall went squirrely with revenue, and dig into that and try to find which channels or which segments that seem to have actually happened in. So for Adobe users, anomaly detection or the intelligent alerts, they're using this exact method. It's Holt-Winters forecasting. I say it's not the exact method. They're using Holt-Winters forecasting. They do a couple of things a little bit differently, but it's conceptually this is exactly what they're doing. They're taking 30 days, fitting a forecast, and then comparing whether things fell outside of that prediction interval. So if you're using Analysis Workspace, this is what's going on. Show of hands, how many people think that's like kind of cool? Okay, that's good. At least you're being nice to me. You don't want the speaker to feel bad, die right now. So that's one example, is I can use it to, I didn't expect anything to change, but did stuff change more than it should have, should I dig into it? But there's a second application of the exact same concept, which is I made a change. I redesigned a landing page. I rolled out a campaign. I updated the homepage. I can do basically the same thing. I can say, let me take the data leading up to when I made that change, use that to build a forecast, and then compare my actual results to that forecast and start to objectively quantify what was the impact of the change that I made. So can't do an A/B test for everything. This is kind of a rigorous way to do a pre-post analysis. This was using what was called the Holt-Winters forecast. There are other forecasting methods. There's Bayesian time series. If you like to say Bayesian, really sound fancy. Be careful if you say that to a data scientist. They may expect you to know a lot more than you do. But conceptually, those are doing the same things. use some historical data, build a forecast, compare my actual results to that forecast. So that's about it. If you're thinking, wow, this stuff, if I did enough of this stuff, that's going to give me the answer. It's going to get me to the truth, right? It's going to get me clearly, if I just do enough of this stuff, we've clearly just scratched the surface, but I can see how the machines start cranking through my data in much more detail and starting to find things and finding real differences and making changes and seeing if those changes have a real impact. That's going to get me to the world of, I fully optimized your marketing, Dave. So here I have to be a cold dose of reality. Analysts, do one more show of hands. How many people know this Dr. Deming quote? In God we trust, all others data. Analysts love to use that one. And the idea is you've got the marketer with their opinion, but I'm the analyst. I have the data, which is true. I have the facts, which is true. And then analysts will sometimes say, I actually have the truth. And that's not true. That kind of bothers me. So I actually don't really like this quote that much, but I quote this guy, Matt Gershoff, CEO, co-founder of Conductrix, who says, and he's been saying this to me for years, at least for 6 years. We found evidence this morning that it's been at least 6 years, that marketing is inherently decision-making in conditions of uncertainty. We're dealing with human beings. There is a cost reducing uncertainty. So even if you had infinite resources, you're not going to eliminate uncertainty. And as we're building the machines and trying to get more efficient, we have to be trading off between when do we try to put more rigor into our models and invest more in building our machine, and when do we say what we've got is good enough for us to make decisions and act and move forward. So at this point, there are two possible reactions. There are three. You could be asleep, but so far nobody's hit the floor. So one is you could be excited, say, oh, this is cool. I finally actually understand how I can get web analytics data and do some basic statistical operations. I see how we make that first little leap to get the data that I can work with. Might be terror, like, holy crap, that looks complicated. It might be both. This describes me. It definitely means I'm not going to be bored as my career goes forward. So now here's where I'd love to say, so these are the specific things you can do to fully ramp up to be more thinking about data differently and more able to work with your data scientists. And I can't. It's still very new. There are not perfect courses or books, but I'll give three slight recommendations that all sort of get at it a little bit. Jim Stern's new book, Artificial Intelligence for Marketing, is got a lot of examples that are not marketing, but he does a pretty good job of saying of these examples, let's think about how this can map to marketing. I also sort of think Matt Gershoff almost should be co-authored because I think he's quoted in every chapter. But that's a good read. And there's a lot of stuff pulled together to say, let me start to understand what that future kind of looks like. This is a quote early on that it sounds a little over the horizon, and it is, but it's only just over the horizon. Another, have to put in a plug for the Measure Slack users. There are people here, awesome. So it's free to join, couple thousand people, pretty well organized. You will not be added to the data science channel by default when you join, but if you join, go to channels, find data science. There's always kind of a good discussion running there with people who really know what's going on and those of us who are really trying to figure it out. And then finally, if you are saying, he keeps saying R, every visualization shown here was built in R, so you can do visualizations. The ANOVA was done in R, the 2D post-hoc analysis. If you want to dive in, there's a website, dartistics.com, which is built to help web analysts get into the world of R, kind of ramp up from the very beginning. And we're continuing to kind of build that out. And it's a totally free site built in R. So with that, have I run horrendously over, mildly over? This presentation is available for download as a PDF at bit.ly/Seer machine. So if you're a data scientist and want to rip me a new one, the evidence is there for you to dive in. And I do have to plug the Digital Analytics Power Hour, which we did have an episode drop today, which a couple of people said they listened to on their drive here, which was kind of awesome. With that, any questions? Any questions that aren't one level deeper than a Tukey post-hoc analysis?
Back.
So when you look at noise, as you showed, do you ever compare it against
what you'd expect from Pearsonian statistics, do they normally hold up?
When you compare what to what?
The noise that you get, you showed a way of coming up with a noise.
Yeah.
Does that really, how close does that come to Pearsonian statistics?
I don't know. I know I've done enough research on winners to say there are critics of it and others that have said it's pretty simple and straightforward, that it seems like a pretty good mechanism for that whole cost versus trade-offs. So that's where I am not a statistician and want people who can help us come up with the recipes to figure that stuff out. Will, this is scary.
No, not scary at all. I think the seasonality stuff that you showed, I was like, damn it, right, yeah, ooh, that's good. Because when I look at my data, it's like Monday, Tuesday, Wednesday, Thursday, Friday, Monday, Tuesday, Wednesday, Thursday, Friday, and it makes it really hard to suss out what the trends are. So I wanted to start looking at that. What's the first one or two things that I need to do to start to be able to suss that out?
It's a good. There was an awesome. There's a guy named John Foreman. Anybody know Analytics Made Skeezy? So John Foreman, a guy named John Foreman, he's at MailChimp, I think, wrote a book. Actually, this example has to be in his book, where he actually goes through how to do a Holt Winters forecast using Excel. So you can kind of build it. I need to double check if it's in the book. He had a blog that was Analytics Made Skeezy, where all the statistical stuff was built around drug dealers. Does anybody know that? It was so fun because it was like he'd have a drug dealer who was trying to forecast cocaine sales, and he would walk through and do a Holt Winters forecast in Excel, step by step. I mean, that was like, I went through that example, and I'm like, I understand enough. Like, I still can't talk exactly how that trend actually gets projected, but I got to a point where I'm like, conceptually, that's like my fourth iteration of trying to explain that time series decomposition, and it is, because I've always, you log into GA and you see this and you're like, fuck, I don't want to look at it in daily. That doesn't tell me anything. But it turns out there's richness and there's value in using the data that way. So goodwill, you should be excited. I'm excited about that. We've got the front. Oh.
Hi, thanks for a great talk. My question is, what is the current state of AI products for marketing? And what are the biggest roadblocks to the development of AI technologies for marketing?
I think we've got a hype cycle issue, right? AI has become the big data where people are starting to think I'm gonna be the voice of Matt Gershoff, where we have a perception that AI is the solution to every problem, and we're waiting for the tools that are AI. And Matt will beat the table with. People don't understand what it is, and therefore they think it's going to solve every problem. So I think there's an expectation. It's a buzzword, and that's why I think. And people will say, "Look, you're talking about statistics. Machine learning is not statistics." I'm like, true, but I do think that if you shift over to statistical thinking, that is a key component of machine learning and AI and all of the stuff that is really cool and fancy. A lot of the examples, though, are coming from places that actually do have the equivalent of BigQuery data, a bunch of data, very detailed, that's high quality. And there are tons of cases in marketing where we don't have that. We still got to connect the dots to be stitching cross-device if we're going to try to do any AI around cross-device. So the biggest challenge, I think there are a lot. I think we're at this super exciting point where things are happening a lot. Mark Edmondson, who's written like every Google R package, he's playing around with voice, some of the Google packages for voice translation and entity analysis, and starting to push stuff into Google DeepMind or TensorFlow, and finding ways to kind of use the data. So more of those examples that bubble up, the more they'll be repurposable. And I think there are whole companies that's basically their pitch. We're optimizing your creative using AI. How much is hype versus reality? We're going to have to wait and see. Oh, we got two more.
Great talk.
Thanks.
My question is, it might be two questions, but how do I bring this into my organization? So I currently see this as me building out a lot of reports that we already do and applying these methodologies. how do I not create an immense amount of work for myself in doing that? And then secondly, maybe with that, how do I get the organization, business users to maybe think a little bit more critically about that high level, Monday to Friday trend and get away from that and start thinking like this?
So my experience with my clients, who none of them hired me to do any of this stuff, was I had to start with actually a little bit like Dave's talk, I had to read between the lines and figure out what questions they were asking that I thought I could solve. Super tactical one was, this site does $15 million a week in revenue, but it's got bots that are constantly cropping up that are not getting filtered out by Adobe. And so I said, this is annoying enough. It keeps throwing off like some of our key metrics, our conversion rate. We'll see visits go up. And then I have to go sift around and try to figure out which are bots and then go add them to a segment to remove them from the virtual report suite. So I said, I should be able to solve this mechanically. Let me do something with median absolute deviation that looks for the last 6 weeks and just bubbles up for combinations of operating system and domain for I have like 5 things, and can talk more about it. But basically, I found problems that this stuff could solve, and then once I'd sort of solved it, so if I was inside a company, I would definitely be doing stuff on the side, like finding my time, evenings, weekends, lunches, whatever, and say, let me do some cool stuff, because it's really hard to make the huge leap to this for an organization. As to how to not be creating more work for yourself, I guess if you're ramping up with like you're giving yourself a lot more automation skills anyway, and you're also giving yourself the ability to provide people with self-service stuff. But in the short term, you will. But if your organization has data scientists, it is a consultant, the number of organizations I see where the data scientists are way over there and the web analysts are way over there, and they literally cannot understand each other. Somebody has got to start to bridge that gap. So I think that's the other way to look at it, is if you're an organization that has data scientists, moving down this path and just understanding it better means you start to get permission to go knock on their door and say, hey, let's talk. Let me tell you, our data is time series. I know that time series data, there are books written about time series. There are courses taught. It is this whole other thing for statisticians. All of my data is time series, but speaking to it, saying time series or non-stationary data, speaking their language, it's just like we used to need to partner with, and we still need to partner with developers for tagging. To me, this is the next opportunity to say we got to partner with the data scientists. Yeah.
Thank you so much for the presentation. I had a question about outliers. And so when you brought up the example of Walmart, the Walmart campaign, and when you're making the box plot, you kind of like get rid of the outliers, right? So what can we do to measure those outliers? Because like those can be effective, like create another campaign to try to replicate that. So do we just totally get rid of them, or what do we do with them?
So I think that's one where because you identify the outliers, and then you can, in some cases you want to keep them in, because if I want to plot the total is the total. In some cases I want to pull them out. There's I think kind of a forking to say, identify the outliers, figure out which ones I can identify. These are outliers where I can hone in on the cause and ask, is this repeatable? Because I could call the brand manager and they'd say, yeah, no, Walmart's never going to do that again, so I need to dig in deeper, versus maybe I found some on paid search that every Wednesday was cropping up as an outlier. That doesn't really seem like an outlier. That seems like something's going on Wednesdays. So that's a little, what you're trying to do. And that's what definitely outliers and median absolute deviation have been like, it's an art and a science. There's not a hard, fast rule, which is another, you can never get a statistician to say anything is the truth or wrong, which is good. That's the statistical thinking. We can't eliminate uncertainty, but it's very hard to pin a statistician down to say, what is the hard and fast rule whereby I should apply which technique? And that's something else I think we just need to figure out as an industry. You're going to go, you sweating over there? You're going to get started late? Carry on?
Yeah, we're about time.
Okay.
Real quick question.
Jim, you can ask your question.
Bold. The guy who's crashing on your couch tonight is going to make the session run along.
So, given the topic of your podcast that I listened to this morning, thank you for that. What do you see as the future, let's say the next 5 to 10 years for a web analyst? Is everyone going to be learning R or Python or SQL? Or, if someone doesn't take that initiative to learn those tools or those skills, where are they going to be in the next 5 to 10 years?
I think as we came out on the podcast, there's still plenty of room for lots of people to do kind of whatever they pursue. I do think there's a need to get one level deeper of understanding on this stuff, even if it's just stuff like this. Oh, suddenly I sort of understand what an ANOVA is. I can now talk to the analysts who are more technical. I do think there's going to, I grapple with that. I don't know. There was a podcast, this one was kind of a Redux podcast because we were saying, for a while, I said the future web analyst is a data scientist. And I think I was dead wrong on that. But I do think this is kind of the next iteration of where, yes, a good web analyst needs to understand tag management and the DOM and jQuery enough, even if they're not pushing out the stuff, the actual code. And I think this is the same way. And thank you.
All right.
Sorry we took that long break.
That's all the time we have. We got to keep moving. Thank you.